All right, I wanted to finish the demonstration that I started last time on debugging. You'll get more practice in this in your not tomorrow's hack, but when you come back from break. The hack that you have, you'll walk through a couple of examples of debugging. We'll walk you through those examples in that hack, but then after that you'll actually use GDB to debug. I believe it's a tic-tac-toe problem or tic-tac-toe program that has several bugs in it. And again, the whole reason that you want to use a proper debugger is because you don't the poor man's debugging of using printf statements everywhere is extremely brittle. You can always say it's okay up to here, it's okay up to here, it's okay up to here, and that'll work until it doesn't, because what you're doing is you're putting stuff to the output buffer. And the output buffer is non-deterministic. In other words, you could have stuff like a bunch of printed A, B, C, lines A, B, and C, and then an error occurs, but A, B, and C, A made it to the standard output and was printed, but B and C never made it there. And so using that is really brittle. It doesn't actually tell you where the error occurred. Only if you're using a proper debugger can you actually come down to the line where the actual problem is occurring. Now again, a debugger is a tool that you can use that simulates the running of a program. You can stop its execution. You can go forward step by step. You can set breakpoints so that you can run up to a certain point and then run over to another point, like a certain line number. The debugger that we use in this class is GNU's debugger, or GDB. Right? Remember that you need to compile with this -G flag in order to preserve all of the symbols, the function names and the variable names and all that stuff, because all that stuff is normally lost when you compile it to machine code. So again, there are several ways that you can use it. You can start your program using run. You can break at a particular function. You can look at your code using layout. You can go next to the next line, or shorthand it as n here. You can print a certain variable or print an entire array of variables. And at this point, let's go ahead and take a look at the rest of that program that we were working on, the array program, which is buggy. And remember, I'm going to use that G flag. That's just short for GNU's debugger, GDB. And if I run it, of course, I get the wrong answer. Let's remind ourselves what this program is actually doing. It fills this array with a bunch of primes, the first 7 primes, and then it sums them up. And if you want to add these up really quick, I believe that the correct answer would be 58. Okay? Now, we already diagnosed 2 bugs from last time. For example, one of the bugs was that we were in an infinite loop because we forgot this I++ down here, and we were able to stop the debugger and find out where in our program what the infinite loop was occurring. The second issue that we had was that this primes was never being allocated correctly. We called malloc, but we called malloc on the next line, and we didn't actually make the pointer primes point to it. So those are both fixed now, and it actually runs without a segmentation fault or anything like that, but it gives us the wrong answer. So I'm going to go ahead and load GDB up here. I'm going to load my program up into GDB. And you'll see that we're sitting here waiting for input, and I can run the program, and of course I'm getting the wrong answer, but it ran the program immediately, instantly, and it didn't stop and tell me what's wrong. I need to actually go into the program step by step and see what's wrong. So what I'm going to do is I'm going to set up a breakpoint. I'm going to set a breakpoint at the main method, or the main function here. I'm also going to say layout next so that I can actually see my code. Nothing is running right now, so no source code is available. When I run, then it stops, immediately stops in main, right? It also preserves all my comments. That's cool. So I've got n here. I go again. I could go ahead and go next, or next if I spell it correctly, or I could go ahead and shorthand this next. Now I could say, oh well, maybe there was a problem in my assignments. Let's go ahead and verify that each one of those was set correctly. So I can print primes. Well, if I print primes, that's just a pointer, right? That's just a memory location. So I need to print primes, say the first one, right? And that correctly received a value of 2. Okay. Print primes 1. That correctly received a value of 3. Print primes. Now I haven't set this value here in the third one because that's the next line that's going to get executed. And so you see that it's uninitialized. I can go ahead and go next here and go ahead and print primes sub 2 and see that it was changed. Well, I could do this piecemeal, or I could go ahead and do them all and then see what the entire array looks like. Now, how do you print an entire array? Well, if you print primes, again, that's just a memory location. So what I need to do is I need to print primes, dereferencing it, and I also need to tell it how big it is. 7 elements in that. And if I do that, it prints out the entire array for me without having to me having to print out each one individually. Right? Now, again, the syntax here is you need to dereference it, right? And then this @ symbol, which is not used in C. This is a GDB thing. And then 7, the size of the array, because even GDB doesn't know exactly how big it is. I could do something like print primes and say that it's of size 8, but of course it's going off into memory that doesn't belong to me, thinking that there's something there because I told there was something there. Okay? That's also a way that you can truncate things, right? If you only wanted to print the first 4 of them, right, you could do @4. Right? You could go to the middle of the array. Let's look at the end of the array. Print. Let's see. Primes of 3 @4. Will that work? Yep. Yep. From the 4th element and then on to the next 4 elements. Right. So you can use syntax like that. All right. Well, I'm convinced that there's nothing wrong with the assignment of the array here because it has the first 7 primes. So let's go ahead and go with next. Next. Well, okay. All right. It was 7. So obviously, and sometimes it'll screw up in the highlighting here. So you can always go refresh. There we go. So obviously something happened inside this function. I got back the answer of 7, and the answer of 7 is wrong. So what I want to do is I want to set a breakpoint in that function, break into the sum, and I want to jump into that function and see what's going on in that function because obviously the problem's inside that function. Now I can't do I can't back up. Backing up would require you saving the state of the program at every single line, and that's way too much and way too unpredictable. So what we're going to do is we're going to rerun the program from the start. Right? I still have refresh again. I still have that breakpoint at line 15. I don't have to go next, 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 next. If you want to continue from one breakpoint to another breakpoint and there are 50 lines in between, you don't have to say next 50 times. You can just say continue. Right? Continue on to the next breakpoint. Refresh. Nope, no refresh was necessary there. But why did it jump immediately down to line 33 here? Why not line 31? Well, those are just variable declarations, right? Print I, print total, right? There's nothing to set up there. There's nothing to debug there. Those are just variable declarations. So let me go ahead and go through this. And all right, so it's going. If I print I now, it's still 0. So when I get through the first iteration of that while loop, then let's see if total is updated. Yep, total is updated. One thing I forgot to check. Let's make sure that we receive the array correctly. Right? Let's go ahead and print array, and there are 7 elements in there. Yep, we received it correctly. We received the first 7 primes here. And the first one was 2, so our total is okay, 2. If I go next, our total should now be 2 plus 3, which is 5. Print total. Okay, that works. Next, print total. Okay, yeah, that works because the next prime is 5. I don't want to have to do this over and over and over again. So what I'm going to do is I'm going to set up a watch on that variable. I want GDB to watch that variable for me so that every time I go through and it gets updated, it automatically prints it for me. Next, oh, it updated to 28. Next, it updated to 41. Next, it updated to 58, which is the correct answer. At which point, the loop is over, and I have the correct answer here, right? Print total. All right, well, if I go next, and I return back to the calling function, and I go next print s, I didn't get the correct answer. Did you see what was wrong? I had no return type, right? I had no return statement. And there is a way to print the return value here. But the real solution here was, I wanted to do this to show you how to use a debugger. The real solution here is to do what? wall, right? Use the warning all flag. And it would have told me this, that the control reaches the end of a non-void function. You didn't return anything, right? And if I'd used WAll, then it would have been obvious to me immediately, oh yeah, I forgot my return statement here. Another issue that's not showing up right now is that I didn't initialize total. Some systems that might have resulted differently because it would have been filled with dead beef or some other random value. Right? Now when I go ahead and run it, no warnings at all, and I get this correct answer. So I was able to debug at least 3 bugs in this program properly by using a proper debugger. Right? So again, I've only shown you a very small amount of what GDB is capable of. You can print variables, you can print entire arrays, you can break at particular line numbers. If you've got multiple files, like 5 files that you've compiled all together, as long as you've used the G flag, you can set a breakpoint at in a certain file in a certain line, and it'll do that for you. You can continue and you can watch a variable, right? So those are the basics, and that's enough to get you started for next week. Questions on debugging? Yeah.
How does it work when you're calling a library that you
Good question. How does it work if you're calling, say, a standard library like printf?
No, when you build your own functions and you have them.
If you're building your own library, as long as you use the G flag, you can and you compile it into a.out, then all that stuff is preserved, and you can run a debugger on it. The problem is with shared library, like the math library or the standard library, you'd have to recompile all that stuff from source in order to debug and run through that stuff. Generally, you don't concern yourself with that. You trust with 99.999% certainty that there's no bugs in the standard library. And if there are, then that's a much bigger issue than what you can deal with. All right. Okay? All right. So with the remainder of our time, I wanted to go over a midterm exam review. And this was just posted on Piazza as a reminder of what the exam is about. It's on Wednesday, so 1 week from today. It's a normal time, 5 o'clock to 6:15, so an hour and 15 minutes. It's right here in Henslick, same room, same time. It's open book, open note, and required computer. You'll be doing live coding exercises. You'll turn your code in via web hand in and use the web grader to grade your stuff. You can turn it in. There's a bug or something. You can turn it in as many times as you want in that 1 hour and 15-minute period. And the last one that you submit, that's the one that will be graded. If you do not have a working laptop, you need to notify me immediately so that we can set up Proctor over in Lab 15. We cannot guarantee a distraction-free environment in there, but at least you'll be able to use a lab computer. Alternatively, you can check out a laptop for a week, I believe, from Husker Hub or Husker Tech or whatever it is. One of the locations is just right outside this door. You'll have to make sure that all the programs that you need to compile and run stuff are there, like PuTTY or Atom.io or something. So make sure that you are taking care of that well in advance of the exam. It's worth 100 points, which translates to about 10% of your grade. It'll cover everything up to and including arrays, but not strings, other than stuff that we like static strings where you use double quotes, right? Printing strings, stuff like that you've been doing from the very beginning of the course. The best way to prepare for this exam is to make sure that you understand all of the hacks that you've done up to this point, and have a substantial start on assignment 3, because that's where all the array stuff is covered. And so, of course, also have a good break and good luck on that. Any questions about the format of the exam? Yeah?
Is it going to be graded on like formatting and stuff like that?
Same rubric, generally the same rubric as everything else. So make sure that it's well formatted, but of course that's far fewer points than correctness and design. Right? Yeah?
So we're just going to be sitting in here on our laptops working on it?
Yes.
Okay.
Yep. Okay. To give you a taste of what it looks like, here's last year's midterm. Right? This is from fall 2018. The first one was just give me points because we've done FizzBuzz in here. We did FizzBuzz in there. FizzBuzz is simply just write a C program from scratch. So we didn't give any starter code on this one. We do give starter code for the other two, and we'll take a look at that in a second here. And by the way, there's not going to be a handout. I'm going to give you a URL up here. And so you do need network connectivity, of course, because you do need to turn stuff in. But I don't want you to have to write this down in your browser. So instead, it's a clickable link, and we'll go to that in a second here. But the first one is write a full C program from scratch that solves the classic FizzBuzz problem. Output integers 1 to 100, 1 to a line. However, if the integer is divisible by 3, then output fizz instead of the number. If the integer is divisible by 5, output buzz instead of the number. And if the integer is divisible by both 3 and 5, in other words, it's divisible by 15, then it should output FizzBuzz instead. Name your source file FizzBuzz and then hand it in. So since we have gone over this, do we want to do a review of it and do it again? Anybody? No? Oh, okay. I'm not, if there are strong feelings that you do want to see this, then go ahead and raise your hands now. No? Okay. Wow. All right. Fine. Given two arrays, you can compute their dot product by multiplying the elements of each element together and then taking their sum. So for example, if I have these two arrays, each one is of size 5, containing 1, 6, 7, 2, 3, and then the next one is 9, 4, 2, 5, 2. The dot product would look like this. You take the first two, so 1 and 9, and you multiply them together. You take the second two, 6 and 4, and you multiply them together, etc. 7 with 2, 2 with 4, 5, and 3 with 2, and then you sum them all together and you get the answer of 64. Write the following C function that computes the dot product of the two given arrays, which are assumed to both be of size n. So you're given an array called A, an array called B. Are you going to be making changes to those arrays? Nope. You're just going to be multiplying their components together. They're both of size n, and then you need to put the result into this pass by reference variable, because the return type here is going to be an error code. The return value should be used to indicate any errors, return 0 for no errors, and return a non-zero value for any type of error. It doesn't matter. Place your prototype and documentation into arrays.h and use your definition into arrays utils.c. So very similar to what you've done on Hack 7 and what you're doing on assignment 3. A tester file has been provided to you to troubleshoot, but you don't have to hand it in. That's the shared code right there. There's array tester. So I'll go ahead and highlight that and bring it over here to say, okay, there we go. I'll go ahead and create a new file called arraytester.c, right? And cut and paste that stuff. So I'll go ahead and go new file array utils.h. And let's go ahead and document this thing. And you can go back here and you can cut and paste this if you want, to make absolutely sure that you're not going to make a mistake. There. So the dot product. Standard documentation. This function computes the dot product, that is the component-wise product summation, however you want to say it, of the two given arrays, each assumed to be of size n. That's good enough. Okay. All right, and then I'm going to create an array, new file, array utils.c, and this will be our actual implementation here. Do I put documentation in the source file? Nope. Do not repeat yourself. Right? Okay, so help me out. How should I start this? Probably going to want a total, right? Int total. Is that good? Nope. What should I do? 0. Initialize it. Right? And then what kind of a for? I'm obviously going to iterate over this stuff. So what kind of a for loop should I make? What kind of a for? For int I equals 0. I is less than n I plus plus. It's the idiomatic for loop that you use to iterate over an array of size n. Total is equal to total plus, and now I need to take the ith component from A and multiply the ith component in B. What's a way that I can shorten this up? Plus equals, excellent. And I will return total. Is that right? Nope. What's the return value again? The return value is the return value should be used to indicate any errors. The total is the answer. Where do I need to put the total? I need to put it in result. So is this correct? Result is equal to total. Nope. This is a pointer. This is a regular old variable. How do I make a pointer variable into a regular old variable so that I can manipulate its contents? Careful. Regular variable into pointer is ampersand. The other way, pointer variable into regular is going to be star operator, right? The dereferencing operator. Now I'll go ahead and return 0 because everything was great, right? So did I do any error checking? Nope. I need to do some error checking. Should I do error checking down here after I've leapt? Look before you leap. So where should I do my error checking? The very first thing. What's one kind of error that I should check for? Null pointer. If A is null, what else could be null? Or B is null? Then return 1. Right? Else if, what's another time? Or, yeah, good. Result could also be null. Or result is null. I'll check all 3 pointers there. Doesn't matter. Else if, what's another type of error that I could have? Okay, n is less than 0. What about, I've seen a lot of people assume, well, what if it's 0? What's the dot product of an empty vector? 0. Just sum it, and that will work here because you start off at total is 0. If n is 0, then this loop will not execute, so you end up setting the result equal to 0, and everything's fine. Right? That's fine too. Return 1. You can return a different error code if you want to. If you really want to, you can go back to your H file and define an enumerated type with all the types of errors that you want to return, and then come back over here and take care of that. I won't go that extra mile there. Right? And we were not. And when we graded this exam, we were not expecting that, right? Because we didn't give those explicit instructions to do so. So there's half the exam in 10 minutes. Right? So you get the you get the scope of the exams. They're not going to be anywhere near as difficult as, say, a hack that you have plenty of time to work on, plenty of people around you to ask for help and get help, or certainly not an assignment where you're doing it alone. You are doing this exam alone, though. Last year we had 50 points bonus. This question is for bonus and is optional. Given 2 arrays A and B, you can append B to the end of A, resulting in a new larger array. This is not string concatenation because these are not strings. It's kind of like string concatenation in that you have one string and then you add the other string at the end. For example, if I had the same arrays here, 1, 6, 7, 2, 3, and 9, 4, 2, 5, 2, then if I appended them together, then I would get 1, 6, 7, 2, 3. That's the first array. And then the second array it just immediately comes after it. Right? Write the following C function where you're given A of size n, you're given B of size m, so they don't necessarily have to be the same size. It could be 3 and 5, and the total would be 8, right? And so I have to give both of those sizes. And it returns a new array. In the event of any errors, you should return null, because that's the only thing you can return. There's not a return code here, an error code. Place your prototype in the same files as arrayutils.h and arrayutils.c. No testing in file has been provided because this is bonus. Right? Okay, let's come back over here, and let's get our bonus points. There. Add some documentation, first of all. All right. This array appends the second, this function creates a new array. Just a second, Siri is messing up. If there's a way to get rid of Siri permanently, let me know. She won't answer me. How do I get rid of you permanently? She doesn't say, tell me how to do it. This function creates a new array that contains the elements from both of the arrays, with those in A appearing first, then those in B appended to the end. Right? Good enough. Let's go over to our array utils over here, and let's write this function. So you help me out. How big is the new array going to be? N plus n. So I need to call. Can I create an array like this? Int result of n times m. I could do something like this, but is that right? What kind of an array is that? That's a static array. Can you return a static array if it's allocated on the stack? What happens to that stack frame when you pop it off? It's gone. Bye. What do I need to do instead? I need to call malloc to get a dynamic array allocated on the heap. Call to malloc. Now, what are my parameters going to be here? What do I need to cast that return value as? Int star to match the pointer on the left-hand side. How big is it going to be? You told me that it was going to be n times m. Oh, n plus m. Thank you. Is that it? Remember, malloc takes the number of bytes, so times the size of an integer, because that's what I'm creating. Now, is this going to work? Yeah, make sure that you put parentheses around here to elevate that operation. Eventually, I'm going to return result. But what do I need to do before I return it? I need to fill it up with the elements, right? I need for int I equals 0, I is less than n, I plus plus. I will copy into result sub I, a sub I. Right? Then I'll do the same thing for elements in B. Except, what have I done? I rewrote everything, right? If I copied these 5 elements, I'm just simply overwriting them with the elements in B. What do I need to do? I need to keep track, and I need to start here. So where do I start? At where? N or n plus 1. So now if there are 5 elements in here, 0, 1, 2, 3, 4, I would start at 5. So it's just going to start at n. Right? And then I would go up to, okay, n plus m. Now you're doing all of this in terms of result. Right? This is where I have to adjust to get down to 0 through m in the B array. Right? I minus n. Right? Why? If you start at n, right? If I subtract n, then the first value will be 0. Then the next value will be 1, 2, 3, 4, etc. Right? Now, if that was confusing, that confuses me, by the way. But I would have done it differently. I would have gone 0 up to m so that I didn't have to think about an offset on B. I would just go I here. I would have thought about the offset on result plus n. This is the exact same thing, though. Right? Or n plus I is what I would have written. Either one of those is perfectly fine. Okay? That looks good, except for error checking. If A is null, or if B is null, or n is less than 0, or m is less than 0, then I will return the only thing that I can return, null. Okay? Now, I haven't compiled any of this stuff. I haven't tested any of this stuff. Let's do that now. I need to, there we go, exit out of this. Notes, I think are in there. 1198. All right. GCC, compile it. Compile the first one with the C flag, array utils.c. All right. I'm getting a lot of errors there. Why? What should I have done? At the very top, I need to include everything that I'm going to be using. Standard library. Am I using input output? Nope. But what am I using? I need to include my own header file, right? Include array utils.h. Good. And then utils.h, you don't include anything. And it's already conveniently included over here for me. So let's try that again. Great. It produced this array utils.o. Now I can compile everything into a tester file, array utils.o and array tester.c. And I can see if it works. 63, that's exactly the answer in the handout. Now, I didn't have any testing code. We didn't give anybody any testing code for the bonus because that's what bonus is. So let's go ahead and do that now. Let's go ahead and add this here. Let's see. Int star combined is equal to append a of size n, b of size n, just because they're the same size. And then I will need to verify that this works. So I could send this into GDB and test it out if I want to. I'll go ahead and just have a regular old for loop here that prints them all out. So I is less than, how big is the combined array? 2 times n, right? I, or n plus n, I plus plus. Right? Printf, I'll just go with a comma delimited list here. So %d, comma, and combined sub I. There we go. And I won't worry too much about formatting because it's just a tester, and I'm not even going to hand that in, so it doesn't matter. All right. Is that correct? 16723 94252. Take a look at the handout, and it matches. At this point, I would hand it in, see that it passes 100%, and I'm good to go. If you do get done before the time runs out, that's perfectly fine. You can go ahead and leave when you're done. Just don't make a disruption. If you think that you're going to leave early, try to sit on the corners and so that you're not stepping over people to try to get out. Right? That was last year's midterm. Okay. If you want to, I've got. Let's see. You don't want that one. We could look at that one in a second, but. I've got spring 2018's midterm. The first one because we've got 45 minutes left if we want to continue just looking at programs here. Write a full program to determine if 2 circles intersect with each other or not. 2 circles will be represented by their xy coordinates and a radius. So it's centered at x and y in the Cartesian plane, and it has a radius of r. So you're looking at, it's centered at this x and y, and then radius going outward. That's a circle. The second circle is at a different x and y with a different radius. Whether or not 2 circles touch each other is simply a matter of determining how far apart their centers are. Because it's just a distance. Take the center, and compute the distance between them, which is given by this formula right here. And if that distance is less than the radius for the first one plus the radius for the second one, that means that they overlap. If that distance is greater than their 2 radii, then they don't intersect. They can intersect at a point. When d is equal to the sum of the radiuses, they only intersect at a point, and you do want to detect that. If so, they intersect. If not, then they do not intersect. Write a program that reads 6 values from command line arguments, not interactively, but command line arguments, and outputs whether or not the 2 circles intersect. For example, I've compiled the a.out, then invoking the program using the circle centered at 0, 0 with a radius of 2, and the circle centered at 2.5 and 2.5 with a radius of 1, would output something that looks like this. This was wrong. This is a typo right here that we corrected in the exam. While the input, if you go from 0, 0 with a radius of 2 and 0, 2, so 0 and 2 with a radius of 1, well, that's a large circle and a small circle, and they definitely intersect because they almost overlap. Right? Place all of your code in a file named circle intersection. That's one. The second one is determine how many zeros an integer array contains. Starter code has been provided, and just similar to the other one. So in other words, iterate over an array and count up how many zeros are in there, and then return that value. Right? Is that it? Just 2? Okay. Yeah, just those 2 things. Let's do the more substantial one here, the circle intersection. I'm going to steal some stuff, right? I'm going to steal this main stuff over here and bring it in over here. Of course, I'm not going to be using a radius hill, so I'll get rid of that. But that's another thing that you can do to prepare. If you've got code that you've written in your hacks, in your assignments, in your labs, it's open book, open note, open computer, go ahead and bring that. If you think that there's something useful and you can cut and paste it really quick and that takes care of half of the exam for you, go ahead and do that. All right, so what do I need to do? I need to check to see if there are a correct number of command line arguments. If argc is not equal to 7, why 7? Well, 3 for the first circle, x, y, and r. 3 for the second circle, x, y, and r. And then also the executable file name. So if I don't get 7 command line arguments, I'm going to echo an error, printf, error, provide 2 circles, or whatever. You don't have to get fancy with it. Exit 1. Right? Otherwise, I know that there are going to be 7 arguments, and so I can go ahead and use, say, doubles, because as in the example here, get rid of this now that we're done with that. In the example, we do have things that are like 2.5. So we do need to support fractional values here. x1, I'll go ahead and call it x1. How do I convert arg_v sub 1 into a double? A to I? F, right? Likewise with y1 and r1, except they're at 2 and 3. Why didn't I start at 0? What's in 0? It's the it's the program's name. Do this again. x2, 2, and 2. And by the way, you could write out radius if you want to. x1, x2, y1, y2, those are coordinates, right? There's really no better name for them. If it's mathematical stuff, then you go ahead and use the mathematical values. Well, if it's pi, you should use the math library anyway. And by the way, we're going to use the math library, so bring in the math library. Right. Fix the white space. There we go. What am I missing up here, though? To do header documentation. My name, et cetera, et cetera, et cetera. Right. So these variable names are perfectly fine in this context. Okay. Oh, but what's wrong? 4, 5, and 6. I was nearly a victim of my own copy pasta. Right? Don't copy pasta unless you are really, really careful about it. So I've got all the values. What I need to do now is compute the distance. Right? I wonder what happens when I try to cut and paste it. Okay, yeah. Let's go with double. Double distance is equal to, well, it's going to be square root of x1 minus x2 squared. So you could use power here if you want, to. I'll just go ahead and do it like that. Plus y1, y2 squared. There we go. Get rid of that. There's the distance. And now I just need to check, is that distance less than the sum of the 2 radii? If distance is less than r1 plus r2, then I know that they are really close together, right? The radii are so therefore they're touching. So printf, they touch. Now you'll probably want to go back and make it look like this. This circle and this circle do not intersect. I'll go ahead and cut and paste this here. I'll use this formatting. So how do I change this? I don't want always 0%. If they're floating point numbers, F. Right? And you can limit them to 2 if you want to. I don't care. Right? Remember, as long as you are giving as much information, at least as much information as the web grader, that's perfectly fine. But of course, I would need to put them over here. x1, y1, r1. x2, y2, r2. That's good. Else, these circles do not intersect. Right? There we go. And return. I'll put a return 0 here so that I don't get that warning on the web grader because you are returning an integer here. If you don't return it, warning, that's not correct. Right? Oh, say again? Oh, good job. Less than or equal to, right? Because if they're equal, that means that they are touching, they are intersecting at a point. Okay? And did I have that in the handout? Yep, less than or equal to. Good. Thank you for that. All right, GCC, what was it, circle intersection? No problems. Provide 2 circles, good. I don't know, one centered at 0, 0 with a radius of 1, one centered at 1, 1 with a radius of 10. Those certainly intersect, right? They do intersect. Another circle of 0, 0 with a radius of 1, and then up at 10, 10 with a radius of 1. Those certainly do not intersect. Yep, do not intersect. So I'm fairly confident that it works. I submit it. I see that it runs 100 test cases. They all pass. I'm good to go. All right. Questions so far? No? All right. Do you want to do this one? Yes? OK. Starter code has been provided. I don't know if this link is still alive or not. Just, oh, OK, it does. All right. You may so just this. Here, I'll just cut and paste this. Right? Obviously, if we give you documentation, we're probably not going to grade on it unless you erased it for some reason. Right? So I'll just put this in the same library over here. This function takes an integer array and counts the number of values in it that are 0, returning that result. If the input is invalid, this function returns -1 because you can't have -1 zeros in it. So this is another convention. That if it's 0, then that means that doesn't mean that there was no error. That means that there were no zeros. If it was 5, that doesn't mean that there is an error. That just means that there were 5 zeros. If it returns -1, though, you can't have a -1 zeros in an array. Right? So that's another error flag that you can use. Let me go over here and implement it. So let's do some rudimentary error checking first. If ARR is null, or if the size is 0, or less than 0. If the size is 0, then there are no zeros in it, so we should return 0. I'll return -1. Oops, -1. There we go. Otherwise, int number of zeros. Well, we haven't seen any yet, so we'll initialize that to 0. For int I equals 0, I is less than n, or size in this case, I plus plus. If ARR sub I is equal to 0, then number of zeros plus plus. And return number of zeros in the end. All right. Questions on that? That's why I was surprised you wanted to see it, because it was much simpler than the other two even. All right. So that was from Spring. If you want to go out even further, I've got Fall 17. Right? Now this is from a different class that used Java as well, but we can translate this stuff. This one's a little bit more challenging than I would give in this class. Because it involves a little bit more mathematics. I try to strip as much math as possible from this class. But you are likely familiar with the factorial function. So just remember the factorial function is 5 factorial is 5 times 4 times 3 times 2 times 1, giving you a result of 150. In this exercise, we're not going to compute factorials. We're going to compute the opposite. Given 120, you would output 5, because 5 factorial is equal to 120. So you need to work backwards. 120 is the input. 5 is the output. One way that you can do this is by counting down, right? 120 divided by 2, divided by 3, divided by 4, divided by 5, until you get down to 1. I'm going to solve it a little bit differently, though. This is, I kind of when I gave this, I kind of regretted giving this as a red herring because there's a much easier way of doing it. Just go in the opposite direction. Of course, not all values will result in the factorial function. In such cases, you will report a lower bound and an upper bound on the value of n that the number falls between. For example, 150 is not the result of any factorial, but it's between 5 factorial, which is 120, and 6 factorial, which is 720. Right? So again, this is a red herring. Look at it the other way. 1 time, or if I start computing it from 1 times 2 times 3 times 4, at some point I might go beyond the input n. At which point I know stop, that is the upper bound. Well, where's the lower bound? Just 1 less. Right? So that's what I'm going to do here. That if the input is 120, then it'll be 5 factorial. Otherwise, if it's 150, then you output something like this. Right? And it was for Java, but we'll do it for C. Right? Let's go. What I'm going to do is I'm just going to copy circle intersection so I can duplicate. And what should I call it? I don't know. Inverse factorial, inverse fact. Right. To do documentation up here. Don't provide 2 circles. I'll just need 1 value. So the executable file name and then n. Right? And don't provide provide an integer, a positive integer. Well, technically 0 factorial is defined. What is 0 factorial? 1, right? Because it corresponds to permutations, the number of arrangements. So 4 factorial is the number of ways of taking 4 things and rearranging them. 1 factorial is just 1, because if you have 1 thing, there's only 1 way of arranging it, this guy. But if you've got 0 elements, how many ways are there of arranging them? Just 1. You do nothing. Right? There's only 1 way of doing it, basically. Right? All right, so this is an integer instead. So int n is equal to, now it's not a to f, it is a to I. I can get rid of the rest of this stuff, all of it. Now, the way that I'm going to compute this is, again, I'm going to go into a loop computing the factorial 1 times 2 times 3 times 4 times 5 until I've exceeded or I've met n, at which point I need to stop. So I'm going to need a value, some temporary variable to do that. Int, I'll call it fact. I'll start it at 1. While fact is, actually probably want to do some error checking here. If n is less than or equal to 0, then printf undefined. I don't know, whatever you wanted to print out there. Right? And then exit with an error code. Okay. Otherwise, I'll have factorial has started at 1. While factorial is less than or equal to, I'm not sure, less than or equal to n, I will go ahead and say factorial times what? Times 2, times 3, times 4, times 5. So I'm probably going to need another variable. I'll start that at 1. Factorial is equal to factorial times I, right? And so should I start it at 1? If I start factorial at 1 here, well, you can if you want to. What do I need to do to set myself up for the next iteration, though? I++, right? Oops, there we go. So factorial will be, let's walk through this the first time here. Factorial is equal to factorial sub I, so it's 1. Then we increment I over here to 2. Then we multiply this together. So now I've got 2. I increment this to 3. 2 times 3 gives me 3 factorial, and I've run out of fingers over here. So 3 factorial. I increment this to 4. 4 factorial, right? 5 factorial. At some point, I will exceed or meet n, right? So maybe I keep going until I'm past n or equal to n. Right? Now, when I've done this, I just need to distinguish between whether or not I hit n or I'm between 2 values. So what kind of a condition would I want? Printf percent %d is equal to, what was the, this is the input, percent %d is equal to percent %d factorial, end line. So I will print out the input, which is n, and then I, right? Because that's I is 1, 2, 3, 4. right? If I hit it, then it's 4 factorial. So what condition do I need to check here to see if it's exactly? That 120 is equal to 5 factorial. No? N equals factorial, or fact, right? If they're equal, else I know that they're not equal, so I've gone past it, right? So if I've gone past it, then I print out, what was the other alternative? Something that looks like this, where this is %d. There. This is going to be %d, and this is going to be %d, and the line, there we go. What is it going to be? I has gone past it, so it'll be I minus 1, then the input n, and then I. Right? We might be off by 1, I don't know, but we need to check that by actually running this and testing it. Right? So let's do that. Use the WAL flag. Inverse factorial. Everything looks fine. Right? Provide a positive integer. I should probably try out with 120. 120 is equal to 5 factorial. Ugh. Is that right? Nope. Okay. Well, let's try 150 and see if I get what I want. Is that right? Nope. But what do you see as the commonality between everything? Everything is off by 1. Right? So what could I do? I could do that. But now I might be off on the first iteration if I gave you 1, right? This will work. I'll show you that this will work. I think. I hope. Yep. There we go. That'll work. That'll work, right? And you can test some other things. But if I do 1, well, that'll work. 2, it's 2 factorial. 3, yep, that'll work. Okay, so I was wrong. It will work with everything. 4, 5, 6. What's the next thing? Well, there. 7, that lies between those two, and I should go up to 4 factorial, which is 24, right? So let's go 1 less, 23, and then 24. Yep, great. So all that works. All that works out. The other solution would have been to leave it as it was, and then just account for everything, subtract off 1, undo the last iteration. Okay. Still have time if you want to do more. Don't worry about that one. Here's another one that works on arrays, since you wanted to see more array stuff. The Hamming distance of 2 strings or of collections of equal length is defined as the number of positions of our elements in which they disagree. For example, the 2 binary strings 0, 1, 1, 0, 1, 0, 1, and the second binary string 0, 1, 1, 1, 0, 0, 0. They differ in the ones that are highlighted here in bold, these two, and then the last one. So the Hamming distance in this example is 3 because they disagree in 3 of those bits. Write a function that computes the Hamming distance of 2 arrays, lists of integers. Again, that's Java, forget that. That hold binary data. So in other words, you're only expecting 0s and 1s in these arrays, right? And if you don't see a 0 or 1, you should return an error code. Did I have starter code on this one? Surely this is dead after a year and a half. Nope. All right, fine. There we go. Let's do it. So GitHub never deletes anything, apparently. All right. And let me go ahead and put it in array utils over here as well for the documentation. So again, a review here. The function computes the Hamming distance of the 2 binary arrays, both of the specified size and places, the value of into the last parameter. So another pass by reference value, because the return type here is going to be an error code. An error code is returned for any potential errors, including the case that either A or B contain non-binary data. So if they don't, if it's not 0 or if it's not 1, then we will return an error code. Okay? So a little bit more challenging, but still doable. First, I need a total. Int ham, I'll just say dist is equal to 0. And that's what I'm eventually going to ham dist. Oh, I've already got ham dist. All right, total. Ham dist is equal to total. Right. And then return 0. So let's do some error checking first. What kind of errors could I have? If A is null, or B is null, or size is less than 0, or ham dist is null, right? I'll go ahead and return 1. Otherwise, I'll go ahead and compute the total here. I could go through once and see if it's all binary, and if not, then immediately stop and return a value. I could go through the second one once, and then if there's an error, and return an error value if it contains 2 or something like that. But there's no need to write 1, 2, 3 loops when I can do it all on the fly. For example, for int I equals 0, I is less than size, I plus plus. Right? If, now here's where I'll do my error checking. If a sub I is not equal to 0 and a sub I is not equal to 1, or you can, you say if it's say a sub I is greater than 1 or a sub I is less than 0, right? You can do something like that too. Or, and then the same thing for B. There we go. B is greater than 1 or B is less than 0. Then I don't need to compute the Hamming distance here because this is non-binary data, so I'll return an error code. Right? I'll line this stuff up. Else, and you could put it in an else here if you really wanted to, but I'll just go. If I return here, there's no way that I'm going to come over here to the else. So the else is kind of superfluous, and you don't need it here. Otherwise, if a sub I is not equal to b sub I, then I will say total plus plus. They disagree. If they're equal, then you ignore them and move on. Right? And I've got a total here. I put that into ham distance, and we're good to go. Right? Any questions on that one? All right. The last one was, oh no, that was the last one. Right? I can keep going back if you want to. I've got 10 years of exams if you want. And they're all different. Pretty sure they're all different. I'd have to dig. All right, so again, to remind you about the formatting, it's 1 week from today. You have that hour and 15 minutes. It's open book, open note. If you print things out, fine. But it's required computer. You can use whatever you want on your computer, except you cannot use it or any other device to communicate with anybody in the class or outside of the class, of course. You'll be doing live coding exercises. And by the way, I do stand up here and I handle any problems like with the grader or stuff. But at the same time, I'm monitoring IP addresses. So because there have been issues in the past where people have hired somebody outside, and we can detect that by looking at their IP address, and somebody submitted something from Iowa, right? And that we can very easily find that out. If you do not have a working laptop, make sure that you go to Husker Tech, Husker Hub, or contact me in order to have a proctor set up in Lab 15. Otherwise, make sure that you review all your labs and hacks and assignments and get a very, very good start on assignment 3. Have a good break.